Okay, so today we're going to be covering section 2.9.1. So you need to have your student workbook with you. Tear out pages 229 through 235, and you begin by working on the warm-up. All right, so let's take a look at Julian here. Okay. I don't want any of you coming in and telling me you're going to fish tank. Okay? All right, so who wants to describe the pattern in the problem number 1, and what would the next number be? Alessia.
You're adding 2, and the next number will be 9.
All right. Plus 2, plus 2, plus 2. So our next number would be 9. Nice. How about number 2? What's the pattern there? Stephanie?
You're adding 5 to every number.
So plus 5, plus 5, plus 5. Our next number would be 33. All right, how about number 3? Number 3. Tina.
You subtract 3 every time, the next number would be negative 8.
All right, so minus 3, minus 3, minus 3, minus 3, negative 8, and then our last one. Yeah. I agree with the... Are we subtracting 7? There you go. We're going to add 7 each time. So what would our last number be? Constant. Okay. So we looked at this kind of stuff before, right? We looked at sequences before. We looked at patterns that we saw. So in this case, we're looking at a sequence, which is a set of numbers, and they have a pattern. And in each case, we're either adding or subtracting an amount. We talked about this before. Do you remember what letter we use to denote that when we have this kind of sequence? We use the letter D, right? The difference. What's the difference between the numbers? That's what we're looking at. So in this particular case, D equals 9. In this case, D equals 5. In this case, D equals negative 8. Okay, because we're adding negative 8, which is subtracting 8. And in this case, D equals 7. Okay? So let's go back and look a little bit at the definition, describe a little bit more about this common difference. So this is called an arithmetic sequence. I don't expect you to write all these words down. Okay. It's an arithmetic sequence, and it's a list of numbers that are separated by a common difference, meaning by the same amount. Common difference. It's the number that's being added. Common difference. Okay? When we graph it, it is a linear function. When we go up by the step.
I have a question about number 4.
Let's go back to number 4.
Where did you put the 7 from? Is it, for the other ones, you put, yeah, number 3,
Oh, you're right. I was writing the wrong things down.
I was going to say it, but I didn't.
Oh my goodness. That's the only one I did right, girls. And it's on video. Yeah. Okay. Rewind. And start over and act like I did it correctly. How does that look, Stephanie? Thank you for calling me on that. Oh, 5 was right. Got that, Doctor?
Yeah.
this one is negative 3. Okay, so I had 2 out of 4 right. That's not bad. 50%, that's enough. Okay. So I can redeem myself now, because we started out with an F. All right. So now we're back to linear functions. Okay, when we talk about functions and they change by the same amount each time, we say they're linear, right? When they change by a different amount each time, we say they're exponential. So we have 2 different ways that we can express the rules that we come up with. We can write rules for a pattern, for a sequence, okay? And we're going to look at both of those ways. So first, we are going to write the explicit formula. We used this term the other day, explicit, when we were writing some equations. And explicit means you can plug in any x and you get any y out, right? So it doesn't matter. You have a nice formula. If I give you an x, you get a y out. The thing is, we're going to use slightly different variables here, okay? And we saw these before. Just you remember back in Unit 1, or early in Unit 2, I don't remember where it was, when we graphed the sequence. Remember, we just graphed the points and we didn't connect them? Do you remember what we put on our x-axis? It wasn't x. Remember the letter?
Wait, I remember N, but I
Right.
don't remember what was it first one?
And that's the other one.
I think I remember the other one.
What's the other one?
Is it A?
Right here. See that?
Oh, A.
A sub n. So it was n and a sub n. So we're going to go back to that. Really, for this case, the explicit formula says for any n, you can plug it right in, and your a sub n comes right out. Okay? So again, it's a function. Function machine input goes in, something happens to it, and something comes out. So in this case, the first thing we need to do is find our common difference. Is there a common difference? What's happening each time? Alexis?
We're adding 6 every time.
We are adding 6. So our D is 6. Okay? And that's our common difference. And the way we find our common difference, well, let's talk about this. So our input each time, when we have a sequence, they are separated by commas. Okay? And when we talk about the n value, that's the position that it has in the sequence. So this is so 3 is our first number, right? 9 is our second number. So when we talk about n, we're talking about where is it in the sequence. Not what is the number, where is it? Okay? So if I said, what number is the 4th term, because we call it a term. What number is the 4th term in this sequence? Which one is the 4th one? Everybody? 21. Okay? So I would say when n is 4, what's this number in the sequence? When n is 3, what's the number in the sequence? 15. So our input is always n. Which number? What place does it hold in that sequence? The a sub n is our output. That's the number. So in this particular case, if we wanted to find a sub 4, that means I go to where n is 4. 1, 2, 3, 4, up. A sub 4 is 21. So that's how we read that, okay? And the way we find the common difference, so to find the common difference, we take a sub 2, which is the second term in the sequence, and we subtract a sub 1. We take the second term, subtract the first one, and that tells us the difference between the numbers, right? Difference So in this case, it's 9 minus 3. So D equals 6. Now you guys were able to figure out it was 6 just by looking at the pattern, right? But sometimes it's not as easy to see. So if you don't see it right away, just do this. Now, we have to make sure it continues. So check 1 or 2 more times to make sure it continues. We found it was 6. 9 plus 6 is 15. 15 plus 6 is 21, so we're good. Okay? Now, when we talk about writing our explicit formula, let's look, I'm going to rewrite the sequence here. A little bit bigger. Okay. So to get from 3 to 6, what did I add? I'm sorry. 3 to 9, what did I add? 6. Okay. Good. Plus 6. Okay. So in this case, a sub 1 equals 3, right? And a sub 2 equals 3 plus 6. Agreed? To get from 3 to 15, how many times did I have to add 6? Twice. Right? To get from 3 to 21, how many times did I have to add 6? 3 times. To get from 3 to the 5th term, how many times would I have to add 6? 4. Pattern, let's look a little bit more closely at this pattern. So let's see if we can rewrite this. I can rewrite this as 3. This is 3 plus 6, right? This is 3 plus 2 times 6, 3. This is 3 plus 3 times 6. I want you to look at something. What's the relationship between this number? Oh, the video, they don't know what number I just pointed at, do they? This number, here we go, and the number in the parentheses. So in this case, actually, I only did it once, right? This is a 2, this is 1. This is a 3, this is 2. This is 4, this is 3. Got the pattern. And I want you to answer this question with your group. If I were to write this, a sub n is equal to 3 plus, tell me what I would write in there. I want you to write that and fill in the parentheses. Talk it over with your group and fill in the number that would go there. All right. So, n minus 1. And that makes sense when we look here, right? To get from 1 to 2, we only take 1 half. Right? To get from 1 to 3, we go 1, 2 times. To get from 1 to 4, 1, 2, 3. So the number of times we add the common difference is always 1 less than the n value. Make sense? Okay. So this is the exact same problem. Don't worry. Just wanted to have a clean slate. So in this case, if we look back at what, let me put up one of those scenarios that we had. We had a sub 4 is equal to 3 plus 3 times 6, right? 1 less. So if we had a sub n, 3 is our a sub 1 value, right? Our starting value. A sub 1 plus n minus 1 times d. Okay? That is our all right. So, in this case, let's find a sub 10. Okay. We could pick up our calculator and go 21 plus 6, plus 6, plus 6, plus 6, but we're not going to do that because we have this cool formula we can use now. So we're going to take a sub 10, take our a sub 1 value, what's our very first value? 3, plus 10 minus 1, right? And our d value is 6. So 3 plus 9 times 6. 3 plus 54. 57. Okay? That's pretty cool, isn't it? No matter what n I give you, you can find an a sub n, right? If I said find a sub 101, you can find it, right? So our explicit formula, any n I give you, you can plug it in, you can come up with an a sub n. All right. Now, let's look at this. This is kind of a goofy looking formula, right? So let's see if we can kind of clean this up a little bit. Make it look like something that makes more sense to us, I guess what I'm saying. So if we go back to our formula, and we say for any a sub n, we're going to start with 3, right, in this case. We're going to take n minus 1, and we're going to multiply it by 6. I want to simplify this side. So what should I do to simplify? I can distribute my 6, right? 3 plus, let's distribute the 6, 6n minus 6. Right? Do I have like terms I could combine? Yes. Then it's equal to, so 3, well let's put the 6n first. 3 minus 6 gives us negative 3. What type of equation does that look like? What type of function does that look like? Linear, right? Doesn't that look like y equals mx plus b? It is. Okay? So we can go from our explicit formula down here to the linear version of it. So we could graph this then. Remember, with n on the x-axis and a sub n on the y-axis. We wouldn't connect the points in between them, right? These are just the... So in your homework tonight, in practice and in your homework tonight, it will say write the explicit formula. And I have to say they're a little schizo about it because sometimes they'll let you leave your answer like this, and sometimes they'll want you to write it like this. I think you should always simplify explicit. If you can, okay? So this is how I would like to see the answer. When they say explicit, start with this and work your way down here. All right. Let's look at a second example. We'll come back. Here we go. So we're going to write a linear function that corresponds to the following arithmetic sequence. So what's the first thing we have to find? Pattern, which Which letter does that represent? D. So we find D by taking a sub 2 minus a sub 1. Don't forget, these are the n's, these are the a sub n's. 1, 2, 3, 4. This is a sub 1, a sub 2, a sub 3, a sub 4. So we take a sub 2, which is 1, minus a sub 1, which is 8. So D equals -7. Now we plug everything else into our explicit formula. A sub n is equal to, what's our a sub 1? 8 plus n minus 1 times -7. So let's distribute our -7. We've got a sub n is equal to 8. -7 times n is -7n. -7 times -1 gives us, negative times negative gives us +7. Now we can combine like terms. We want to have the value of the term with n come first with the linear expression. So -7n plus 8 plus 7. Good. So I could give you any n value, and you could find what the value is in the sequence, right? If I said, now the key thing is to understand when you hear the word term, find that 10th term. That means n is 10. Find the 45th term. That means n is 45. And so you have to be able to associate n with the word term. Okay. So now we are going to take a step back. Or no, here, we'll go over here. And we're going to define it recursively. We also talked about this before when we talked about sequencing. Explicitly meant for any input, you could find any output, right? Recursive is different. It's different. Recursive means you must know the number before it. So to find the next number in the sequence, you have to know the number in front of it. Okay? So if I say to you, oh, here we go. What's the pattern here? -7, right? We know the fourth term. What's the fifth term going to be? What's the fifth term going to be, Carl? What's it going to be? -20. Because you knew the term in front of it, right? So you take the term in front of it and you apply the rule. That's what recursive means. You have to know the number in front of it in order to determine the next number. So we already knew that D was -7, so if you subtract 7, you get -20. Okay? So we have a slightly different formula. Let's go through like we did with the last one and list out our numbers here. What's our a sub 1 here? What is it? 8. And everybody should be writing this with me. So our a sub 2 is a sub 1 minus 7, right? To find 2, I take a sub 1 and I subtract another 7. Agree? To find a sub 3, I take the number in front of it, a sub 2, and I subtract 7 again. So you always take the number in front of it. To find a sub 4, I take a sub 3 subtract 7, a sub 5, a sub 4 minus 7, and we just keep going and going and going and going. So here's what I want you to do. Tell me, how would I write what goes there if this is n instead of n? Pick a pattern, figure out what to write there. Okay, girls, let's look at what we saw up here. Girls up here. This is 3, this is 3 minus 1, right? This is 4, this is 4 minus 1. 5 minus 1, and this would be a sub n minus 1. You need to know the number in front of it. So it would be a sub n minus 1. So we want to write this in general terms. A sub n would be equal to a sub 1 a sub n minus 1 plus whatever d is. Okay? So this is our recursive formula. It says you have to know the number in front of it to get the number you want. I can't just give you any n like I could with the explicit formula. So this is the recursive Okay. So let's look at example 3. So this says an arithmetic sequence is defined recursively. Okay, so here's another one in front of it. By a sub n is equal to a sub n minus 1 plus 5. So what's my common difference in this case? 5. We're adding 5 each time. It starts with a sub 1 being 29. Here's the other thing. If you have a recursive formula, they have to tell you the starting point. How else do you know where to start, right? You need to know the number before it. They better give you the starting point, okay? So this says find the first 5 terms. So we already know a sub 1 is 29. So a sub 2, according to the formula, is a sub 2 minus 1, right? And minus 1 plus 5. So that's a sub 1 plus 5. So it's 29 plus 5, 30. Do you have to go through all those steps every time? Absolutely not. I'm just doing that to show you guys. A sub 3 is a sub 2 plus 5, which is 34 plus 5, right? So it's going to be 39. A sub 4 is a sub 3 plus 5, 44. And a sub 5 is a sub 4 plus 5, which is 49. So after you have found numbers, please write them as a sequence. So we would write 29, 34, 39, 44, and 49. Okay? You get too close?
Yeah.
I knew you guys would.
I was on the inside, just like we're doing.
Okay. So now it says write an explicit formula. So we have to go back and write the explicit formula. So we're going to switch gears. We're going to go back to this one. Okay? So a sub n, what's our a sub 1? 29 plus 1, and what's our D? 5. So we're going to distribute our 5. 5 times n is 5n. 5 times negative 1 is negative 1. So explicitly, a sub n is equal to 5n, 29 minus 5, plus 3. So now, it says find the 15th term. So everybody find the 15th term. All right. Find the 15th term for me. Not 7. This is 5 times 10. It's not 5, it's 7. All right, get girls. N, you are looking for the 15th term. Again, term means N. So everywhere you see N, put the number 15. So A sub 15 equals 99. Okay. All right. All right, so there is, I'm going to have you do 1, 2, 3, 1, 2, and 3, but let's do 4 together. 4 is hard, okay? Hard because there is a fraction. So let's do 4 first. All right, so to find D, don't forget, A sub 2 minus A sub 1, okay? Because that's a hard D to figure out. So that is 5 over 2 minus 1 over 2, which gives us 4 over 2, which is what? But all right. Now we go to our explicit form. A sub n, A sub 1 plus n minus 1 times d. Right? What's our A sub 1 here? So we're starting 1/2, right? Plus n minus 1 times 2. Are you with me? So now we distribute the 2. 1/2 plus 2 times n is 2n. 2 times negative 1 minus 2. And now we have to combine like terms. Move to 2n. So what's 1/2 minus 2? 1 and 1/2. How would we write that? 1.5, right? So write it as 1.5. How would we write it as a fraction? Not a mixed number. Oh. Okay, so take out your calculators. Everybody take 1 divided by 2 minus 2. calculator say? Okay, now hit math, enter. Give it to you as a fraction, right? So it's negative what? Negative 3 over 2. I would accept if you wrote this. Okay? I would not take 1 and then a little s. All right, now you do 1, 2, and 3. All right, so some of you in your workbooks have, in older workbooks, have an incorrect formula. You don't have a sub 1 here, and you don't have a sub n minus 1. If your formulas for 5 and 6 look exactly like this, you're good. If they look different, then you need to change these two to look like this. And then continue on with complex 5.
Okay, girls, I put up the answers if you want to take a look at those.
Okay, girls, for the workbook problems, I only want you, we did number 4 together, then I want you to do 1, 2, the rest through 8. Don't worry about 9 and 10. The answers are right here. Okay, let's take a look at our learning logs also. We have a session on Monday. Yeah. Let's look at our learning log. So we did, today is day 5, so we covered 2.9.1. On Monday, we will have an assessment just on lesson 8. So that's on days 3 and 4. I know, can you believe it? We're fine. We almost done with it too. Okay, so it's just on when we added, subtracted, multiplied, and divided functions and when we shifted them last night. Okay? That's the only thing. It's 7 questions. It'll be real quick. And then we will finish with another kind of sequence. Then Tuesday will be the review day. And then Wednesday, finally, after what seems like an eternity, we will be done with Unit 2.
Why is 2 so long?
I don't know why they didn't bring 2 up. This first period, I'm assessing on 3 on Tuesday, 7 days. We're going to get through 3 in like 7 or 8 days. That's it. After everything we've been through. All right, so just don't forget there's some assessment on lessons stages 2 and 3. I will put the homework up now if you're done with these, and that way you can get started on the homework, okay?